Hello and welcome to PTC Express Video Tip of the Month. My name's Leo Green. Today we're going to be talking about the field point and its application in user-defined analysis. ProEngineer provides a plethora of analysis options, from measurements, model analysis, as well as geometric evaluation, where you can get shaded plots of drafts and slopes and section curves and curvature and so on to further evaluate the geometry through your modeling task. But what if the analysis that you're looking for isn't on the list? What do you do then? Well, that's what we're going to do today. What if we have an impella here? We have an impella that has a variable pitch blade. We may want to evaluate specifically how that pitch changes as a function of the blade. So let's jump right in. Let's take a look at this model and let's just get rid of some of the extra geometry and let's look at just the blade itself. Okay, so what do we want to do here? We want to evaluate the slope. How do we evaluate the slope, but not just the slope with respect to a plane, this bottom plane here. We want to evaluate the slope with respect to perhaps a flow line. So let's construct the geometry necessary to do that. Well, first we're going to need a point on the surface someplace, then we'll need an axis that goes through the point that's normal to the surface, and then we're going to need to square it to the flow line. So let's build that geometry, doing it just a little different. Instead of just using a regular point, I'm going to use something here called a field point. Now the field datum point provides a point that resides in a domain. So let's just put that point there. You'll notice that it doesn't require offset references. So there's a point on that surface. Let's ask for now an axis that goes through that point and squared up to that surface. So we got an axis there. And so now I want a curve. We'll sketch a curve, but I don't have the plane that I want to put it on yet. So let's put a plane that goes through this axis and that point. Now that's not the plane that I want to sketch on either, but it's getting close, so I'm going to remove that. We'll make another plane that is square to that plane, through that point, and also square to this plane. So let's pick that plane, pick this point, and square it up here. So normal, normal, and through. And that's the plane that I'm going to actually sketch on. And I'm going to sketch using, as a reference, sketch references. So let's ask for this as a reference, as well as that point. Pick from list, and let's find that point in there. There it is. Okay, so let's go to the sketch view, and the angle now that I'm interested in is from the horizontal squared up to that plane. Using some geometry references here, we'll specify this is to be exactly horizontal, and what we'll do is we'll just make these two equal to each other, just for grins. Now, we have a curve, and they're currently turned off, so let's unhide them. So there is the slope angle that we're interested in. Well, if I go to Analysis and ask to measure an angle, measure an angle, bring this down so you can see it, I can specify from that curve to that curve and ask for an angle. There it is, 64.4. Well, that's just a one-shot, one-time deal. Well, I can save this analysis, but I also can make it a feature. If I make it a feature, it then publishes a feature parameter, in this case called angle, and if I want to I can change that name. But I'll leave it as angle, and you'll look in the model tree and you'll see that I now have a new analysis feature called angle 1. Well, let's see what we can do with that. Through the model tree columns, I can ask for a feature parameter called angle, and I can ask to show it in the model tree, and currently it's 64 degrees. I'll turn off the planes. I'll turn off the axes too. Now, what does this mean? this field point thing? Well, if I pick the field point, and I'll do that here, edit its definition, I can drag this point and put it in a different place. When I call this OK, you'll notice that the angle analysis completely updated. I can pick that same field point, edit its definition, I can move it off onto a different surface. And you'll notice again, all the subsequent features updated as well as the angle. Well, what if I wanted to evaluate this angle over the entire surface? Well, I would then use user-defined analysis. Analysis, user-defined analysis. Now you'll notice if I click it now, it says there are no UDA groups in the current model. The key here is local groups. Well, if I grab the field point as a feature, as well as all the features up to and including the analysis feature, right-click and make it a group. So it's just called local group. Let's call it the let's call it thrust ANG. That'll work for us. When I go to analysis, user-defined analysis, I now have this thrust ANG analysis feature where I can specify and compute over the entire, let me put this into the screen too, over the entire domain. So the field point exists in a domain, and what ProEngineer's done now is it's moved that field point around on that surface, creating now a plot. Let's take a look at the computation settings. I might want to increase the resolution on that, and then I also may want to adjust the limits. Let's maybe take this to 70. Let's take this one maybe to 45 and update that. It gives us an idea of how that thrust angle changes as a function of the surface. What's more is I can change my mind here. See, it says default references. I can specify that I want it now to evaluate up there, middle mouse, compute, and that evaluates then the thrust angle as a function of this surface. Very quick, very easy, user-defined analysis, capturing a measurement that's not on the menu. Could be a really pretty complicated construction of many different things. Okay, well, what does that get for you? The ability to evaluate and understand more clearly, specifically, what it is you have in mind. Oh, there's one other thing I'd like to mention about the user-defined analysis. You can specify over the entire field, or you can specify a specific point. So I can pick a point, and there's 71, 66, 65, and so on as I click around on that domain. Okay? So, go back to the entire field, and there you go. All right. Well, I hope a little of this made sense to you, and next time you find yourself creating construction geometry to evaluate a specific analysis at a specific spot, well, consider the field point so that you can just move it around anywhere you care to. Again, my name is Leo Green. I hope that a little of this made sense to you, and hope that you'll be able to use this in the future. So long now.